Welcome to the deep dive. Today, we're getting into something really interesting. We're kind of reverse engineering the mind of a successful bioprocess engineer. I mean, this is a field that's just booming, right? Turning biology into life-saving drugs, sustainable fuels. It's incredible stuff. And, well, the demand for really sharp people is through the roof. So if you ever wonder what separates, someone just starting out from a real leader in this space, you're definitely in the right place. Our mission today is to give you a clearer picture, a roadmap, if you will. And to help us navigate, we've got this excellent resource. It's Kaplan's Guide on the top interview questions for bioprocess engineers. We're going to dig deeper than just the surface questions, really extract the key insights. So whether you're maybe gearing up for your own interview or you're on the hiring side trying to find that perfect fit, this should be really valuable.
Yeah, absolutely. And, that's why this kind of depth dive is so crucial. These questions, they aren't just hoops to jump through. They're really designed to probe, both the technical skills and that critical problem-solving ability. The guide, it really tries to bridge that gap, doesn't it, between wanting the job and actually landing it successfully?
Yeah.
By looking at fundamental principles, specific technical skills, how people handle industry challenges, maybe with innovative ideas. That's how you spot the folks who have the expertise, sure, but also the adaptability, the foresight needed to really excel here.
Okay, let's unpack that then. Let's get into what that really means in practice. We've pulled out 6 key questions from the guide, and for each one, we'll look at what's really being asked, and maybe more importantly, what a standout answer tells you about a candidate. So let's kick off with something foundational. The first question: what experience do you have working with bioprocess equipment and technology? And I guess this isn't just about listing machines you've seen, right? It's about showing real practical familiarity.
Exactly. What's insightful here is it's testing that hands-on experience, yes, but also the understanding behind it. It's not enough to just know of a bioreactor or centrifuge or, say, chromatography systems. A strong candidate, they'll talk about why maybe a certain bioreactor type was used for a specific cell line, or they'll discuss the trade-offs between different chromatography resins and a purification process. That shows an engineering mindset, understanding the why, not just the what. It signals real technical depth beyond just knowing how to operate the equipment.
That's a great distinction, that knowing of versus knowing how and why. So for people listening, whether they're hiring or interviewing, what's a small detail someone might mention about maybe a bioreactor, something that flags up that real depth?
Well, a top candidate might talk about controlling dissolved oxygen profiles, perhaps, or managing shear stress for particularly sensitive cells, and they might link that directly to challenges they face during scale-up. Or with chromatography, they could get into details like optimizing column packing or maybe modeling breakthrough curves. See, these aren't just operational points. They show an understanding of process optimization and also the inherent limitations.
Right, understand the boundaries. Okay, so once you've established that hands-on grasp of the tools, the next logical step is understanding how well they grasp the core biological processes these tools support. So let's move to that next question. Can you explain your experience with cell culture and fermentation processes?
Yeah, and if we connect this to the bigger picture, cell culture and fermentation, they really are the bedrock for so many bioprocesses. A really good candidate, they won't just say, oh, I have X years of experience or list, standard aseptic techniques. They might get specific. They might discuss how they optimize, say, feed strategies to boost titers in a fed batch culture, or how they tackled challenges like osmolality shifts in really large bioreactors. That shows advanced problem solving. Or maybe they'll explain how their grasp of microbial metabolism helped them set fermentation conditions for better yield. Or perhaps how they used PAT process analytical technologies to monitor things in real time.
That definitely elevates the answer, doesn't it?
Yeah.
It shows you're not just following a recipe, but you actually understand the underlying biology and chemistry, and you're actively trying to improve things. Thinking about those fundamental techniques like aseptic technique, are there any common pitfalls or maybe misunderstandings that a really strong candidate would implicitly address or clarify?
That's a good point. A lot of people think aseptic technique is purely about sterility, keeping things clean. But a great candidate understands it's more holistic than that. It involves facility design, air handling, even the quality of your raw materials, how people gown up. They might talk about risk mitigation strategies for contamination, not just saying we were careful. It shows a broader systems thinking perspective.
Systems thinking. I like that. Okay, so while expertise in processes and equipment is vital, we all know things don't always go smoothly in bioprocessing. Which leads us neatly to troubleshooting the question: How do you handle troubleshooting and problem solving in a bioprocessing environment? Because let's face it, unexpected issues are pretty much guaranteed.
Oh, definitely. And this raises a really important point because these environments are so dynamic. Problems aren't just likely, they're, well, part of the job description, really. So a standout answer goes beyond just a generic problem-solving method. It might involve explaining how they'd use, say, PET data to quickly spot deviations, or maybe how their understanding of cell metabolism helped form a hypothesis for why yields suddenly dropped. That shows diagnostic skills specific to our field, you know. The best answers usually describe a structured approach. First, gather all the relevant data, then use bioprocessing principles to figure out potential causes, develop a plan to test those causes, and crucially involve the right people, other teams, stakeholders to make sure the solution is effective and considers everything.
I really like that emphasis on data-driven diagnosis. Can you maybe walk us through a quick sort of hypothetical example where that systematic approach really made a difference without obviously giving away any secrets?
Sure. Let's imagine a bioreactor batch suddenly shows a drop in cell viability. Okay. A structured approach wouldn't just be check the temperature probe. It would mean pulling all the trend data, dissolved oxygen, pH, maybe CO2 levels, nutrient feeds, and comparing it carefully against historical data from successful runs. Now, if you saw, for instance, a subtle dip in the glucose feed rate before the viability started dropping, well, that points towards a potential nutrient issue, not necessarily an equipment malfunction. So your solution becomes much more targeted, right? Maybe adjusting the feed strategy rather than launching a huge, time-consuming investigation into the reactor itself. It's about using all the data points to build an informed hypothesis.
That's a really clear illustration, thank you. And building on that idea of tackling problems, let's get into specific stories. The next question prompts for that. Can you discuss a particularly challenging project you have worked on in a bioprocessing setting? This is really where a candidate can show off their resilience, their ingenuity, maybe how they learn.
Exactly. And it's not just about describing the challenge itself. It's about the journey to the solution and critically what they learned from it. So a strong answer will detail a specific project. Maybe it was dealing with unexpected issues during scale-up, from pilot to manufacturing scale, or perhaps optimizing a tricky purification step for a very sensitive protein. The candidate should clearly lay out the main technical or maybe operational hurdles they faced, and then, most importantly, describe the specific, perhaps innovative approaches they use to get past them. And finishing off by stating the specific, measurable results or outcomes. That demonstrates real impact and shows they can actually deliver solutions under pressure. It really speaks volumes about their ability to learn and adapt.
Yeah, this is where it gets really insightful, I think. For you listening, this is your chance to craft a story that doesn't just list a problem, but showcases your unique way of thinking, your problem-solving muscles, and crucially, how you grew from that experience. Turn that challenge into proof of your value. Okay, so we've talked about skills and problem solving, but this field moves so fast, right? So continuous learning isn't just nice to have, it's essential. Which brings us to, how do you stay current with advancements in bioprocessing technology and industry trends?
What's fascinating here is that this question really probes a candidate's dedication to their own professional growth and whether they're truly aware of just how quickly things change in this industry. And importantly, how they engage with that change. You know, it's not really enough to just passively scan a journal title now and then. Effective strategies mean actively reading peer-reviewed publications, yes, but also attending relevant conferences, maybe seminars, to hear about the latest research and applications firsthand. Being an active member of professional bodies like ISPE or AISCE, that matters too, and networking, talking to peers. Critically, though, a great answer connects this learning back to their own work. How did reading that paper or attending that talk maybe inspire a new process idea or a more efficient way to tackle something?
Right, so it's about integrating the knowledge, not just collecting it. Thinking about emerging tech, is there one area, beyond the obvious ones maybe, that you think candidates really need to be clued up on right now?
Good question. Beyond the big headlines like cell and gene therapy, I'd say having a grasp of how AI and machine learning are being applied is becoming increasingly important for process optimization, predictive maintenance, even helping with the drug discovery pathways. Also, definitely an awareness of continuous manufacturing, the techniques, yes, but also the unique challenges it presents for bioprocesses. Being able to discuss these intelligently really shows a forward-looking perspective.
That's really helpful. Okay, finally, let's shift to the day-to-day practicalities. Bioprocessing labs and plants are complex places, often with multiple things happening at once. So the question is, how do you manage and prioritize multiple projects and tasks in a bioprocessing environment?
Yes, and this gets right to the heart of organizational skills, efficiency things that are just vital when you're juggling multiple responsibilities. Effective strategies here, they go beyond just, making a to-do list. A strong candidate will talk about how they maintain clear, detailed project plans, maybe mentioning specific software they use. They'll explain how they prioritize tasks, considering not just importance and urgency, but also the interdependencies between tasks, especially within a complex manufacturing schedule. And crucially, they'll emphasize communication, regular, transparent updates with team members, with stakeholders, to keep everyone aligned, especially when priorities inevitably shift. It shows structured thinking, proactive risk awareness, and strong collaborative instincts.
That focus on interdependency and communication feels really key, doesn't it? Especially when you're dealing with living systems where one delay can ripple through everything else. If you're hiring, that's exactly the kind of answer you need to hear, right? To feel confident someone can handle not just the technical side, but the complex, often high-pressure operational demands. So wow, we've covered quite a bit, really trying to get inside the thinking behind these crucial interview questions. Stepping back a bit, the common themes are pretty clear, aren't they? It's this blend of deep technical know-how, sharp problem-solving skills, a commitment to continuous learning, and really solid project management. They're all interconnected, forming the core of what makes a successful bioprocess engineer.
Absolutely, and if we connect this back to the bigger picture again, it's worth remembering how valuable these core skills are across the whole spectrum of bioprocess engineering roles. I mean, beyond the main bioprocess engineer title, you might find people specializing as, say, an analytical biochemical engineer, focusing heavily on the measurement and analysis side, or a bioengineer, looking at broader biological system design, maybe a biomedical engineer applying these principles to medical devices, or even a biomaterials engineer developing new materials. It really underscores the diversity and the interdisciplinary nature of this field. These skills are incredibly versatile.
That's a great point. So whether you're actively looking for a job right now, maybe aiming for promotion, or you're just curious about this really dynamic sector, understanding these core competencies at this deeper level is, well, invaluable. And remember, that Kaplan guide we looked at also mentions other tools, things like an interview coach or an offer analyzer, which could give you that extra edge when you're refining your interview strategy or weighing up different opportunities. And just like that, we're at the end of this deep dive. We've really tried to unpack those critical questions that shape careers in bioprocess engineering, hopefully extracting the essence of what top employers are looking for and what you, as a potential candidate, need to master. We hope this gives you a much clearer, maybe more nuanced view for navigating this really vital industry.
And just to leave you with something to think about, given the incredible pace of innovation we've touched on, synthetic biology, advanced gene editing, people are even talking about biomanufacturing in space now. How do you think the next wave of challenges in bioprocess engineering might change these interview questions we've discussed? And what completely new skills, maybe things that are quite niche today, do you predict will become absolutely essential, non-negotiable for success in, say, the next 5 or 10 years? Something to